We're going to start by looking at some integrals and trying to decide what integration technique we need to use. Now, first off, notice that number 6 and number 7 look an awful lot like number 5 that we did in the last video. A lot alike. The only difference is this one has an x up here, and this one has an x squared up there. Well, that x and x squared are actually going to tell you that you're going to do this as an entirely different problem. So, here we need to talk about how do I look at an integral and decide what to do with it. A couple tricks. If it's going to end up being an arcsine or an arctan, you need to have a number up here in the numerator. That's the easiest way to tell. That works 99% of the time. It needs to be a constant up there in the numerator. If you have that, then try this arctan stuff or arcsine. This one, start to look at the degree, meaning the biggest exponent. Notice that in number 6, the biggest exponent on top is 1. The biggest exponent on bottom is 2. Notice in 7, the biggest exponent on top is 2. The biggest exponent on bottom is 2. So right away for number 7, that should scream to you long division. Anytime the degree or the biggest exponent is the same on top or bottom or top heavy, you need to do long division. So we'll get to that in just a second, but that one's going to be a long division. This one, it's not a long division because it's not top heavy and they're not equal. It's not an arctan or an arcsine because we have a letter up here. So the next thing you would want to try is just plain old U substitution and see if it works. So if I look at number 6, I am going to say that the bottom is U. Now, if that's you, I would like you to try and pause the video and solve this problem using what we know about U substitution. Come back when you're ready and check your answer. Let's check what you got with what I got. So if U is 3 plus 4x squared, du is going to be 8x dx. Now, if I move that 8 down here, I can see right there is my du. Now, just to compare this really quickly, normally I'd move this 8 out and then add whatever I needed, but I noticed that this one just happened to have the number I needed. If this was, say, a 5 and I wanted an 8, then I'd move the 5 out and then add the 8 and the 1/8 to keep it balanced. Then I have 1 over u du. Integral of 1 over u is ln of u, ln of absolute value of u, I should say, and then plug u back in because it's an indefinite integral, and that's what we get. Okay, let's try number 7. This is a long division problem. I will start by doing the long division with you. Don't forget your placeholders. And then I'm just changing the denominator to be in the right order. So I'm going to start this times what is this? Well, that's going to be a 2. Put it in my number column. Multiply your 2 in. So I get 4x squared times 2 is 8x squared. 2 times 0x is 0x. And 2 times 3 is 6. Subtract all of them. So 8x squared minus 8x squared goes away. 0 minus 0 goes away. 0 minus 6 is negative 6. So let's rewrite this now as my answer plus my remainder over what I divided by. Now, just like for the problem from the first video, we are going to separate these two integrals and deal with them separately. So now that I've gotten you to this point, I would like you to pause the video and try to finish this problem. That integral is not too bad. This integral, we have to think, is this going to be a u substitution, a long division, or a trig, or a arc trig, inverse trig? That's what I'm looking for. Well, I notice I only have a constant on top, and that constant I can take out. So that's going to be an arc trig, an inverse trig. So with those hints, pause the video, try to finish out this problem on your own, and then come back and see how you did. Okay, welcome back. Let's see how you did. So at this point, I've separated them. I started by taking this -6 out and putting it in front. And then at the same time, I took this and put it into something squared. So the 4x squared is 2x squared. And the 3 is going to be square root of 3 squared. So I'm putting it into that arctan form. Now I notice this inside is not by itself. It's joined with a 2, which means I need to do u substitution. So I say u is 2x, so du is 2dx, which means I need to add a 2 right there to get that, and a 1/2 to balance it. So I've got all of that balanced, and I go up here. So -6 times 1/2 is -3. And then I have my u and my square root of 3, my du, and now it's just a matter of applying your Arctan rule. So remember, don't forget that Arctan has that 1 over a in front, and then we have that, and we just have to plug it in, and you're done. So that is it for this video. In the next video, we'll do some more integral problems, looking at, this is integral, what kind of technique should I use?